Today we're going to do roundabouts, our last day on roundabouts. Next time we're going to start into pavement design, which you've seen before, but we'll get back into that a little bit now, a year later, even as a junior class. Today we're going to look at our last piece of roundabouts, which is looking at some of the designs, and particularly ones from the city of Valparaiso, so that they're handy and close, and good chance you've driven through some of them. And we're going to look at the stuff we've been talking about, how to design them, different design elements, what to do with roundabouts. We're going to go through some of these examples to give you an idea what this looks like in practice on some real world roundabouts through there. So just some background, a lot of these notes and whatnot came from Tim Berkman. He was the city engineer at Valparaiso until a year ago. And so he was instrumental in, I think, pushing the city towards building some roundabouts and putting roundabouts in at the, I guess, three main places within Valparaiso where they currently exist, and getting the Silhavy and LaPorte one started. And he left obviously before it was finished last year, but he was instrumental in getting that started as well. So a lot of these pictures and the numbers came from him, when he would know because he was the city engineer and he was in charge of those projects. So it's really good information to have for that. Here's this little background about how much roundabouts have grown in the U.S. From when they started. In 1990, we had almost zero in the U.S. In the mid-90s, they built the first few, and they were out in Colorado near Vail and Avon. Built the first roundabouts in the U.S., modern roundabout in the U.S. through there. And they kind of took off, right? So that was something that when people would travel and go to Europe, they would see these roundabouts, and they work all right, and they seem to be fine. A little scary the first time you drive through them. Through that, and they finally re-imported them back here to the U.S., and they've taken off since then. And you can see the kind of really huge growth in them through there. So when I was working as a consultant back in the mid-2000s, I'd gone to a class to learn how to, in Avon, Colorado, to design roundabouts. And the state officially changed their position, NDOT changed their position to allow roundabouts to be considered, but no one would approve it. They were all afraid of them because they had no background with them. And so we did a project, and a roundabout by modeling would have been clearly superior than a traffic signal, but nobody at the state would approve it. So even though they technically would let it happen, or you could have a roundabout, no one would actually be willing to take a chance and approve one because they were too new from that. Now that changed in the late aughts, I guess, around 2008, 2009. We had a new NDOT commissioner, a younger fellow, and he'd been a design engineer at American Structure Point before he became state commissioner. And he had a whole different view on the roundabouts. And he said, why aren't we using these? And so I think his view was a roundabout should be considered for every intersection improvement. And it's not always the winner. It's not always the best solution, but it needs to be chosen or looked at for each one. And so NDOT started building them, and there has been a big boom. And NDOT, they're not afraid of it all anymore. The consultants know how to do them. They've got a pretty good routine down now. Everyone understands the how to go through it. One of the problems with the early ones, that when we tried to propose, was that the state didn't know how to even review it. At that point, that informational guide, the first one, had just come out. They're like, well, just a guide. We don't even, and they didn't have anybody trained themselves to know how to look at a roundabout and how to approve it. So that's been the big explosion in that, and it goes up every year. And I think in every state now, pretty much, people will look at a roundabout as an option at an intersection, and it's not always the best option by far, but there's enough of them that I think it's always going to be in the mix now. And most of the driving population has come to terms with them. And I still hear when your parents visit and they come to visit the school, and then some complain about the roundabout. They're unsturdy and so forth. You must not have them back home, but they're going to see them more and more. And obviously younger drivers tend to do better with them. So roundabouts, yeah, they've jumped up quite a bit through there. The city of Valparaiso, this is about probably starting 10 years ago, was looking at improving the Silhavy corridor through that. And these projects take a long time, right? So by the time you get the funding and you start design, construction design, for a project, it takes 4 years before you actually break ground and start construction. So there's 4 years of just the design review process. And so that Silhavy Roundabout just got built last year, right? 4 years before that is when it was probably let as a project to a consulting firm, not to get working on. I think DLZ designed that one. But Silhavy, running parallel with 49, is a pretty busy road through there. It connects a lot of important residential areas to the north, to all of that huge shopping center there near the intersection of LaPorte and Silhavy. Obviously down here you can see all the shopping right through there, and there's the intersection that now has a roundabout. So they looked at how to improve that whole corridor through there, and some of it was just going to be signalized improvements. So Silhavy and Evans has a weird lane there and a pole out in the middle, right? That's going to get upgraded, and that's supposed to look like this when they're done with it finally through there. And this will still be a signalized intersection. They're not going to go roundabout here. That's a little bit lower volume, and they've got this house right on the corner. They probably wanted to buy that, and this pond also on the corner, which would be hard to get around as well. So that one has tighter right-of-way restrictions on it, so you couldn't, if you did a roundabout, you'd be bigger out in this range. You would have bought that house for sure, and impacted those two for sure if you went with the roundabout there. And I think it's just the lower traffic there, they decided that the traffic signal was going to be better, but they did add the lanes in, right? So if we go back to here, all right, you've got a single left and a through right, and a left and a through right, and a right and a through left, and a through left and a right. And so now we're adding in extra turn lanes where they're needed. And so now we've got 3 lanes, 2 auxiliary lanes and a through lane on both the north and south approaches, as well as this eastbound approach over here, right? And then dropping back down to the famous one at LaPorte and Silhavy, this is what the intersection looked like before, which you guys remember that now when you started school through there. And this one, the traffic flow wasn't great, but it was actually the high crash frequency, which was the biggest pushing factor for changing this intersection, right? So the number of crashes and the severity of crashes was not good here, and you can probably understand why, and you've used to drive through this. It's at a slight skew angle, right? So it's near that 20-degree limit, so that's not good. There's a lot of lanes, and it's huge, right? This is really wide crossed here, and people kind of get lost, and that's a safety issue when you get such a big intersection like this with all those lanes through that. And especially signalized one, people were, especially busy places, people were trying to beat the red, and they push through even past the end of the all red, and they can get clobbered coming through there. So that's one of the main highest, I guess, one of the highest danger types of crashes. So the highest severity type of crash through there. So what they looked at is a 160-foot inscribed circle diameter. And if you remember from our chart before, that's on the high side. It's a little bit high. 150 is standard for a single lane, but this is all going to be, you'll see in a second here, a multi-lane roundabout. So 160 fits in with that mix. The approaches they were looking at 35 miles per hour coming into the approaches, which is about what most of the approaches already work, except maybe the westbound one coming off of 49, it might have been a little bit higher. Through there in the circle, they're trying to keep it to 25, right? Remember, our range was 20 to 25. In this circle, they're trying to keep it at 25. Multi-lane, you're not going to probably beat that. It's probably about the best you're going to do right through there. In the circle itself, the travel lanes inside the circle are 15 feet wide. Again, any larger vehicle needs a wider swept path, kind of like we did turning lanes before, or turning roadways. We had to widen those out to be able to get the truck to fit through them. So this is obviously circular roads, so they widened those out. Plus, the people are still a little iffy on roundabouts, and a wider lane makes them feel more comfortable. Right? No one's going to get too close to them as they go through that. Right? So that's and this is what the layout looks like through here. And I guess you can be the judge whether it looks exactly like this or not. Now that it's been built, it's close. Through there, we've got a nice bypass lane here, and the eastbound right turn coming in through that. And before, we talked about how to offset these roundabouts off of the center lines, right? And whether you were going to go to the left or to the right or through the center, right? So was one of the issues we looked at. We had those charts, and we talked about the pros and cons of each, right? Let me see if I can get get my pen to work without being crazy like it sometimes is, right? All right, well, here's the little pen, right? So you can see, here's the center of this roundabout, right? So we've got the center is right here. There we go. So we've got that center right there is the center for that. And you can say, well, this approach coming in here, we actually are passing to the left, which means we can have a lot of deflection on the incoming side. And you do, you get this, you look at this, all this deflection for the through movement. That's a huge, this bend and coming around, that's a huge movement. You've got a huge deflection here, right? So if these people coming in off from 49 probably aren't going to go 35, they're probably going 40 or 45, right? They feel like they're out in the open here, at least they used to. And you can see this green area used to be the road over here, right? Here's the original center line through that. Well, now we introduced this extra bend in here. Well, not we, but the designer introduced that extra bend in here that really gets you to slow down, and because this is pretty high deflection. All right, there's my speaker shutting itself off. So you had this huge deflection here, and so that's really going to slow people down to get you to that 25 mile per hour range. Now watch the vehicles after you come through this, and we're going to go down the center line, right? And then you're going to come back out. Don't ask me why I did that, right? What do you think the fastest path is, right? Your most of your deflection is going to be right in here, some going through here, but then it straightens out and it's kind of a straight shot out. Look at this guy down here, right? This is really straight coming out of here, right? So that's not much deflection at all. So once people reach this point, they're probably just going to hit the gas and just shoot right, shoot right on out of here. Maybe not the best. So you got lots of good deflection coming in, all right, like that, and pretty much zero deflection coming back out of it, all right? So that's the trade-off. And so this gets you slow. So you're going to enter the circle at a nice slow speed, and you had to slow down so much and curve here, you're going to be paying better attention. You're not going to try to shoot a gap, and that's the problem with straight entry, is you may try to shoot the gap and get in here too fast. So you're probably not going to try that on this. And so those are all good things, right? So we'll clean that off and get started again. And you can see that this was the original alignment. This line, no, go back, come on. Don't do that. Oh, I just got to turn the pen back on. I thought it was going to remain on. Okay. So this was the original alignment here, right? You can see this line here, little dots on it. All right, that was the original State Road 2 alignment. This used to be probably a 55 mile per hour road through here because nothing was built out here years ago. 20 years ago, I think this was all open field. And so this was designed like a normal state highway, and it didn't actually get into town until you got near campus there, where Sturdy Road is. Right, that was really the start of town, and back in those days, when the original State Road 2 is coming through here. So it was designed probably for 50, 55 miles per hour. That's a nice smooth curve. Look at that. All right, through there. And then as it built up, they just kept that curve, and then they put in more and more lanes and traffic signal, right? Well, it's easy when you get a green light that you can really fly. You can really move fast if that was your original alignment. So in roundabouts, we're completely changing that. Now you're coming in here and you've got this huge arc, right, coming that direction. And you can see they've changed. This is the new alignment line. That's their new center line alignment for LaPorte. And here's their new center line alignment here coming in this direction for Silhavy. All right. And so they've changed those from the original, and they actually do pass through the center to a degree, but with a multi-lane roundabout, it's really hard to get much deflection on this exit. That's another downside of the multi-lane, right? And if we were to draw that fastest path, where would we start and how would we get through here? I don't know if I can do a hand sketch job here well enough, but it would be kind of like that, right? You would start close to this curb. You would widen out. You'd come off just a couple feet off of this inside curb. I think whatever the guide said, I think it's 4 or 5 feet off of that one, and 2 or 3 feet off this one, or maybe it's the other way around. And then you would straighten back out here. That can be a pretty straight path through there. So you're not going to beat 25 miles per hour on this. All right, but this is a good portion of the design. Other things we looked at the splitter islands, right? So here's a nice splitter island coming in. This is kind of divisional, and then this is kind of a refuge piece of the island, and it's also channelization. So we're actually channelizing both these sides. Through here, we've got one of the issues with the original traffic signal that just got replaced was there was no good way for pedestrians to get across, and there was no even walk signs out there because it was originally a rural intersection. It wasn't built to be an urban intersection, and that was such a wide road it would be really hard to get pedestrians across it. Okay. And so now we've got these crosswalks here, right? And we've got these beautiful pedestrian refuges on these. So you're never crossing more than 2 lanes at once, which is pretty manageable, right? Trying to, in the old intersection, if we flip back here, right, you were going to cross 1, 2, 3, 4, 5, 6 lanes, and there is no refuge. And there was a crosswalk, but look how long that is. And it even goes across the widest part of the right turn lane, right? So that's hundreds of feet you'd have to cross, right? That is just crazy. And it's only on one side. That was the other thing. Sorry, it's 2. Right, it's on the west and it's on the north, but there is, well, I guess there was. Yeah. I didn't think there was one on this side, but I guess it just the pavement markings got wore off because it was in bad enough shape, right, through there. But now on none of these approaches, on none of these sides of this roundabout, do you ever have to cross more than 2 lanes at once as a pedestrian. So that for pedestrians, that's huge. That's really big. You've got sidewalks now built on all sides, which they didn't used to be. This side didn't used to have much in the way of sidewalks. This side had nothing at all, really. You're just out in the grass. This was just grass over here. So now we have pedestrian areas as well. And so that's all good. Coming in there. So here's your truck apron, right? So here's all those design elements we looked at before. And it's kind of hard to tell here, but these lanes do widen out as it comes in here. That's the flare coming into it. And then, like I said, in the guide there we just saw, they said these lanes are 15 feet wide on the inside. All right, so that's that. This was one of their original modeling efforts for it. And it was before they had this bypass lane in down here, right? Now they added that in later, right? So this was their original modeling effort for that roundabout through there, and people debate whether they want to put little wiggles in coming in, right? Back here in this, we didn't have the wiggle, but I know here they're showing it. So the roundabout we're going to see a picture of in a second. That's from State Road 19 and 119. They had the wiggle, and then I was talking to the designer a couple years later. They changed their mind. You know, the national consensus became, we don't really want wiggles now. Now we're just going to put more deflection in right at the end, right? So now we have this huge deflection here. This is the final layout, and we didn't have quite that much in this earlier version of that. Right. This is a modeling version where they were calculating whether they had enough capacity to handle traffic well through that. And so this was this is the VISIM model using just the traffic signals. They're modeling, this was the existing layout through that. And so you can build these models, you can run cars through it, and then you can calculate the delay on these vehicles as it goes through. And that's how you can compare different designs right through here. Here was the roundabout, and it looks a little weird, and it's moving really fast. And the aerial picture they use underneath it still has the old road underneath it. So it looks like there's a queue of cars here. There's not really a queue there. All right, so they were just trying out all these different models. And so it's, it's a pretty basic one, kind of more of a wireframe model through that, and not one of the prettier ones. Through there, but that's how you could, as an engineer, test this. And in 457 next fall, we're going to go through and you'll learn how to do these models through that. That's part of that class, right? So here's what they were looking at, the present configuration. Well, this is actually before it got built. And now it's the right column over here is after it's been built. All right, so this was before construction. This is after what they were looking at. It was signalized. They went from a level service D, which isn't good, right? You could be worse. You could be an F. But it goes up to a level service A. So you'll be you can make your own decision about whether you think it has reached a level service A or has been built. Could be. It could be. Sometimes their models are a little optimistic about how well people drive, right? The average delay, what used to be 40 seconds, is 8 seconds. You'll see that fits into which levels of service those are. Right through there, we've got some bypass lanes now for eastbound traffic. That wasn't in the original one through there. So that's just some of the comparisons of that. So the 5 Points one, this is on the north side of Valparaiso. And we got Roosevelt coming up and connecting with Vale Park through here. All right. And so that's the 5 Points. This is what it used to look like in the aerial version for that. And the traffic volumes are fairly high. And when you build a project like this, you do a 20-year projection for your traffic. And that's standard. So they were expecting to build this in 2010. And so they counted it in 2009. And they were projecting it up to 2030. That'd be 20 years after it was built. And so this is their numbers they're expecting. 46,000 vehicles is a lot. For an intersection, that's a lot. If you remember the graph we had about roundabouts and what size they were, you're in the multi-lane area range now if you're going to go up to 46,000. Right? Big accident rates out here as well. 106 accidents over a 5-year period. That's really, really high. Right? Typically, we say 3 accidents. 3 accidents per year is enough to trigger some kind of a safety measure, right? So they've got 106 accidents in 5 years. They're way, way over that trigger threshold for doing the countermeasures, right? So, and they had a lot of head-ons, they had right angles, and they had people disregarding the signal and just doing what they wanted out here. In a 5-lane intersection or 5 approach intersection like this, these are complicated because you had this weird angle here. And especially if you came up here and you wanted to turn left, it's easy to get off track and not know where you're supposed to be, and so forth. And so it's also for signal timing, it's a mess, right? Because yeah, you can run these 2 through movements, right, along the major road at the same time, and maybe you can run these, but then you have to have a whole separate set of phases just to run this road, and only they can go by them. They can only go by themselves, right? Only this road will be flowing at one time. And so it's a very inefficient way to run as traffic signal. So they looked at that. Here was their final design plans for this. And again, it's already built, so you can judge whether they built it appropriately or not through there. And this one's a little bit of a hybrid. You've got one section here that's only a single lane, just because this movement is a lower volume movement. That's usually how they judge that. They didn't need 2 lanes here, so they went with a single one there. Everything else has dual lanes through it, especially, this is our major axis through here on Calumet. So you've got these 2 lanes through here. You've got these 2 lanes coming through here. That's obviously going to handle the most traffic through that. And Vale Park is becoming more and more important as a cross connector along the north side, especially if they finish the last piece over by the high school later on off to the west. They expect that to pick up in traffic as this also goes over to 49 and connects across the top. So they're planning for the future. Again, you design this is actually designed for 20 years in the future, the traffic flow in 20 years in the future. All right, and so you can see here we've got really good deflection, right, coming in there. We've got pretty good deflection over here, not quite as good. We've got good deflection here as well. All right, and decent deflection on Vale Park approaches through that. The exits have a little bit more curve to them, not so much on that one. This one has a little more, this one has a lot compared to the one we just saw over at Silhavy. Being multi-lane and just for the geometry to work, we had to use a pretty big diameter center island here on this one. And let me click back over into pen mode and see if my handwriting is better than it was on the last slide. So we've got this is a pretty big island, and it has to be big because you have multi-lane. The other reason it has to be big is if we had drawn a smaller circulatory island, which would apparently be a very lumpy potato looking thing, right? The angle where this road comes in versus this angle, they would be getting a lot closer together. And so you can use one of the reasons, I'm guessing, they used a bigger radius on this center island out here is that it pushes that circulatory road out further. And now where this is the old right-of-way line for where Roosevelt came in, right? They even swung it off to the east and then brought it back in, right? The center line of it used to be right here. Right, it used to be over here, and here was the center line of Calumet, which they kept, right, through that. Where those intercepted, right, used to be right there, kind of in the, probably would have been here, right? So they've moved the center of that traffic circle down and towards those two, and that's why they can intercept those two vectors, you might call them, coming in from those two approaches further down, so there's not quite that sharp point. So see this right-of-way line, that sharp point, you didn't want that. You don't want these two roads to be too close together. So they bent this over, good idea, and they moved the traffic circle this direction, also a good idea. And that gives you more space right in this region. All right, so this is a big problem with roundabout design, is where these entrance roads are, you don't want that exit to be too close to it. And I am going to clear off all that mess I just made and come back to it, right? So this is a problem area, right? Because you don't want, otherwise if they were too close, you would have been crossing more like right in here, right, and cutting across that. By being able to move this circle down and bending that road out, that gives you more of a perpendicular crossing movement right across in front of those two entrance lanes here on northbound, and that's good, and we like that. And that's good, and this would have been a real problem area, and sometimes you can't get away with using a roundabout even on a weird legged intersection like this. People used to think this is a great place always for roundabouts because you've got more than 4 legs. Roundabout can handle it. It's a circle, right? But it doesn't always work well. Actually, it often doesn't work well to have 5, especially when you have that really high acute angle. So they did a good job here. They did a good job of fixing this up and changing. They made this, it helps to have this be a fairly large diameter, right, in the center island. And then they moved that center island down this direction. So you intercepted those two approaches earlier on, and it gave you more room between the entrance and the exit road through there. So all good things through that. And this is one they would say this is spiral striping. And you can kind of see we've got these pavement markings come out like that, radiating out, and they're kind of spiral striped, kind of. Some people find it confusing, right? But and you can see here we've got a little bit of an inside one painted in here, and that's trying to push you over into this lane because this is through and left. So if you were going on a through moving in Vale Park, you'd want to take that, or you can continue on and probably come out here. It's unlikely if you entered from over here or here that you would come back around and want to be in this lane. So this striping is pushing you out here in this right lane as we come through. So there's the Calumet 5 Points intersection right through there. Safety was the big reason for that. They didn't have good pedestrian facilities at all. A lot of older intersections don't, right? They didn't always consider pedestrians unless it was an old downtown area before. It had a bad level of service, so traffic wasn't flowing very well through there. And it was operating in a D in the AM peak hour and an E in the PM peak hour, right? So PM's peak hours tend to be worse. So that was very bad, right, through there. And here's how we can determine what the levels of service are. Again, you saw these briefly in 252, and you'll see it again if you take the elective in the fall, how we calculate what the level of service is. And this is based on the amount of delay. So the average vehicles were in the morning running somewhere close to 30 seconds of delay, and in the evening they were in the 40 probably range, somewhere between 35 and 50 average delay per vehicle coming through, right? Ideally we'd want to keep it below 15 seconds, right? A and B is where we like to be through here. Here's a standard report that you normally do for a scoping study before you do the starting the design, be the preliminary design piece of this, is where you're comparing what the different options are going to be and how they're going to look, right? So you would have gotten D's and E's and an occasional C on all of the approach roads if you use the traffic signal, right, through there. And that was with existing traffic, right? And then if you look at what's the traffic going to be once it's built in 2012, so after it's got constructed and the construction effects of traffic are gone. If it was, they tried a 4-leg one, they also looked at a 5-leg one. They're getting all A's and an occasional B, right? So it's working actually very well through that. Here's the delay in seconds, right? average delay per vehicle, compared to what it was before. 35 to 72, that should have actually been an F, and so forth. You're, nowhere near even the same order of magnitude really on that. All right, so very big improvement there. This one, just to give you an idea of the money involved, right? This was about a $3.8 million project. That was a lot of approach work on there. That said, a standard approach roundabout, the standard size is going to run you about $2.5 million. This one has an extra leg, and it goes back further down each side. So it's costing them a little more. So it's about 3.7 million total in the end, right, for that. This one's down south of campus, and so north is actually it's in that direction. State Road 2 runs to the southwest out of Valparaiso, and down this is 3 or 4 miles outside of Valparaiso. Comes up to County Road 100 south through there, which is a major east-west corridor. Through that, and it's also got this weird thing where you had a crossroad here. State Road 2 is at an angle, which is never good, right? Running because you would have a high skew angle, and then you had another little county road coming in from the side, almost at the same point, right? So this was also probably a high crash location and fairly confusing for local drivers with all those roads coming in at a single spot. I don't have a before picture really of it through there. So this one was proposed on state highways. This is a state project, and it was proposed to put a roundabout in here and then to curve the side road in, right, and tee it in to State Road 2. And we talked about that back before we started roundabouts, that what you can do with side roads to alleviate those high skew angles when they come in to that, to make them safer. Right now, here you can you can say we just talked about all that time about angles. This is going to be the problem point right here. Right, this is an acute angle coming in there, and maybe a little bit over here. And this one's going to work pretty well because they bent this enough coming in, right through there. This one is still a pretty high angle. And so you can see this exit movement right across this entrance that's still touchy, and they just left it kind of wider open. This is state highway, so they're expecting, a fair number of, WB67 design vehicle trucks coming through. So that's some of the trade-off right through that. This is also, you can watch a modeling of this. This is actually using sim traffic from Synchro through that. It's a little smoother looking than the other one, and we do speed everything up because if you watched cars in real time do this, you would probably really be bored, right? So they're just modeling. This is State Road 2 coming into Valpo up in this direction, right through there, and modeling. Again, it's a little bit more primitive look as a model, but they're showing it could all work through that. Right. This is State Road 19 at 119, and I showed you some pictures from this last time, I believe. As well, of how these cars come in and the design elements you've got, right? And so there is no curb, and got just a ditch out here until you get to the roundabout. Then they're using the curb to help delineate where you're at. So you can see that they've added this curb and gutter in here. It's not common. Normally in a rural situation, you wouldn't just add it because it costs money and you have to have storm sewers through there, but they added it in here, and part of it is traffic feel, and that safety issue is this gives drivers a little bit more of a closed-in feel, right? And more likely they're going to slow down, and more likely they're going to notice something's coming up because they see this early, and it's white, and it kind of shines brightly at night as well, but it catches your eye and informs you something is coming up, right? And if you didn't notice the roundabout itself coming in, so that's a good piece. As we come through, we can see from the Google height all that nice deflection, all right, coming through there with the yield point through this, and you do see a trailer going through, and he's not having any trouble. All right, through that, you still got those nice lines and deflection through that. So that's the deflection on approach. We just jumped back to see that, and that's what we have here. Is they've got this nice delineation coming in. And now they're also checking for trucks to get through here. So this is a 62, not quite Indiana design vehicle size, but probably one more that they might have expected there. I'm not quite sure why they used that model and not the 67 through there. You can see the swept path, right? So they have modeled where this is the front tires, and then here's the rear trailer tires, and that's what the truck apron is for. So they have the truck apron there in the design, and you can see how it comes through, right? So here's this. If you came in with your tractor, with the truck, you have to steer in and then steer way out to get the trailer to swing wider, and you still got some room to play with, right? You've got some boundary room there. They even did a little model of it. We can play this as the truck comes through. I'm sure they had to show this to NDOT to prove to them that yes, they did design it to handle a truck. Right, getting through there, and it didn't even use all of the truck apron, so you could get even a slightly bigger truck through there if you wanted to. Right, do that. This is their fastest path delineations, and we saw that before. This is exactly the chart we looked at before, which comes out of the informational manual. And so you can see this is their, I guess, northbound or northeast bound path through here. This is their first radii, the second, the third. That's delineated here. You see R1, R2, R3. All right, that's what they're showing here. Here's the radiuses that they measured after they drew this in. All right, then they come back and measure it. And then they match them with that chart we were having. And here's the speeds they've got, right? So their R1 is a little high, 27, okay? But R2 is good. R2 is 21, that's good. And then it goes back up to 28. This is a pretty shallow curve on exit coming through here. All right, so in the circle itself, they're where they want to be. They want to be 20 to 25. It's nice if you can get a little bit more deflection up here, but you would have to narrow this down and trucks would have trouble with it. So that's always the issue, right? And look at R4. If you had to come around here, once you're in that curve following it around, you're way down in the 15 mile per hour range, right? Through there. And over here, if you're coming in and hanging a right through that even, then you're going to go pretty slow through there. The maximum maximum radius you can effectively use here is going to be 66 feet, which ties you into 17 miles per hour. Right. And they also looked at the sight distance, and we talked about that before. So this is nice to see their design calcs for this roundabout through here. Here's the approaching vehicle at the decision point where they need to decide, right? This is a yield condition where they need to decide if they have to stop or not. How far back can they see? And they're showing that, yes, you can see back to this point. They can see a car waiting at the yield line. They can see a car circulating around, right? And they can see the yield line itself. And there's no pedestrians out here, so there's no facilities for it. Otherwise, you'd have to be able to see the pedestrian crossing too. Right, so that looks great. The red lines are all for this car going this direction, right? You can see the same lines being used for all of the decision points you need in different colors for each of the other vehicles coming around. The other one they added in was if you're just driving in a circle around the middle, right? How far do you need to be able to see in front of you to stop safely? So in this case, we're using stopping sight distance. For there, you need 80 feet because you're going 20 miles an hour, right? Through there. And so that's, so between this point, driver's eye, and how far you need to see, right? You measure it along the vehicle path. And then you draw a straight line because that's your line of sight. And are there any obstructions in the crosshatched area? No, there's not. And so you could technically start planting shrubs just outside that line all the way around, right through there. Now their truck apron is covering all of that area, so you're definitely safe on the sight distance line. But that's one of the checks you do. For a smaller diameter center island, then this line here, the sight line, may actually be out over the grass or may be closer to the center. It just depends on the size of the vehicle, right? And even then, you also have to check intersection sight distance, right, for all these different approaches. And so this County Road 300 West comes right in just south of that intersection, all right? And if you're waiting here to turn, right, you are prohibited from turning left. And why do you think they did that? We back up, right? So you can't turn left out of here because that's going to be dangerous. By the time you turn left, people can be hauling out of here. And it just adds one more conflict piece. And it's a more complicated maneuver because you're seeing if someone's coming around that corner, is someone coming around here. You're trying to look in two kind of different places a little bit, and you're dividing your attention. And there could be people waiting here to turn in, right? And the reason this works here, cutting this off, is because if you want to turn right, you just come out here, you go around the roundabout, sorry, turn left. You turn right first, you come out here, you go around the roundabout, and then you swoop right on back out. Right. And that's a nice thing that you can do with roundabouts. And we do cut off access like that if you're near a roundabout, because we can allow you to do the U-turn basically around the roundabout through that. So that's all good. Oh, back here. And so his intersection sight distance, this guy waiting, only needs to be able to see to the left. Right. And one of these lines I'm pretty sure would be for if you were a car, and one of them is if you were a truck. That's the amount of sight distance you would need. Right, and you can see it works out pretty well. It never crosses the right-of-way line, which is important, and it stays out over an easy spot to see. All right, through there. And you can see they're checking for passenger cars and single-unit trucks. So that's what INDOT must have directed them to use. And if you were waiting to turn left off the main line, which is group F in our intersection sight distance, right? You're here. You need to be able to see oncoming vehicles, and again, you've got a good sight line to any oncoming vehicle here and here, for single unit trucks and for cars, and you can safely turn left then. So they're showing they've got all those right-of-way lines. This is a really good kind of summary of all those design elements we've been talking about over the last week and a half or so. Right through here. The last thing that we had from these guys who designed this one is this is their lighting plan, right? So you said early on they used to tell us that roundabouts would save you money in maintenance because you don't have to operate a traffic signal there. Right, over the time, because it's a hard feature and there is no maintenance on it. Well, okay, that's all not true. There's a ton of maintenance on roundabouts because there's usually nice landscaping and stuff, and you have other things to fix. There's a lot of curb and gutter that you didn't have before. That's all going to take maintenance. And then over the years, so in the 90s, they said, well, you don't have to light them. They're great. Yeah, we've learned that you do have to light them because people get confused, especially maybe when roundabouts become commonplace and they're everywhere. People won't be as confused, but they generally are. So the prevailing consensus these days is you need to light them, and you need to light them fairly well. So you start back here. Here's the first street light, second one, third one, on this. So these are the pools of light. And so these orange and then this kind of beige color, it's the brightest spot, slightly dimmer, dimmer, dimmer. So this is the edge of your lighted envelope. Right? And there's some lux that they are probably calculating to show this contour plot out there. You can see these purplish areas are the best lit sections. You always want good lighting right here where people are waiting, and there's a merge zone. You have good lighting here where you can see the exit. Right, you can get that approach. If there were pedestrian crossings near here, you'd want to have lights near that. So they've done a good job in lighting all of these entrance areas. Right, doing a nice job there. Even this really sharp bend one. They're doing a nice job there. Also, this side road, because it's so close, they thought, well, we better light this too. Right? These people are kind of all part of this as a system, right? And they even light this outbound side maybe a little more than they did on the others because you've got this left turn lane there. So they're helping delineate that, yeah, here's a left turn lane. And just as a side note, it's been shown that having street lighting does drop accidents by approximately 20% for nighttime accidents. And so that's... lighting intersections, any intersection, is usually a good idea for safety. It's become even more important at roundabouts through there, just because there's a lot of bending coming in, right? A lot of deflection and curves in that road. There's now hard objects, these curbs on these islands out in the middle that people need to avoid. So the lighting really helps with all of that. And so for a more a less common situation, lighting really helps people understand what they're doing. So that's why we use it now for all the roundabouts. All right, so that's our talk through on some examples. A little longer talk than I expected to give on this. And I guess the good news is there was no in-class assignment associated with this because it's just talking and looking at pictures through that. All right, next time we're going to start in on pavements.